right, welcome Algebra 1. Today we're looking at 8.3, solving quadratic equations using square roots. So far we've solved quadratic equations by factoring. We've solved them by, let's see. We might have solved them by graphing them and looking for where they cross the x-axis. It seems like we've maybe done that already. I'm not sure. But another way to do these is if there's no x term in your quadratic, if it's just an x squared with no x term, you can solve them using square roots. And we actually were introduced to this in our last chapter. So yeah, there's our objectives. You see what those are. Oh yeah, it gives it away. We're going to use square roots. One thing you got to realize today is that you're going to have two solutions typically. Okay, so basically, and I like to think of these as graphically. So if you got a quadratic, a lot of times it'll hit the x-axis twice, and you'll get two solutions. So we got to cover that. We got to make sure we get two solutions. But sometimes what'll happen is you'll get one solution. But what's really happening is you're getting that one solution twice. So that's a possibility. And then it is also possible that, let's flip it over. Yeah, it could be that it doesn't cross the x-axis at all and you get no real solutions. So that's what we got to be cognizant of today. So solve each of the following equations. Here's how we're going to do it. We're going to get x squared alone. So we're going to add the 27 over. We're going to divide by 3. And we're going to get x squared alone. Now what we do is we undo the squaring by using an inverse operation of square rooting. But here's the thing. Turns out 3 can be an answer here. 3 squared gets us 9. But also negative 3 gets us 9. Negative 3, the quantity negative 3 squared gets us 9. So we're going to have two solutions here. We're going to get x is equal to 3 and x is equal to negative 3. Now you can either write it separately like that, or you could just write plus or minus 3. Let's try this next one out. Get the x squared by itself by adding the 10 over, and you'll get 0. Well, you can try to do plus or minus 0, but plus or minus 0 is the same answer. So your answer is just 0. You get one solution. And then try this next one here. Divide by negative 5. Get the x squared by itself. And check this out. If you put this into your calculator, square root of negative 1, you're going to get error. So this is an example of no real solution. So anytime you try to take the square root of a negative number, you're going to get no real solution. Turns out there are imaginary solutions, but we'll save that for Algebra 2. But yeah, so you get no real solution. Okay, so those are the three possibilities today. Sometimes what's going to happen is you're going to have to undo the squaring first and then do some more operations. So check this out. To get x by itself, yeah, I got to get rid of this minus 1, but I can't do that until I get rid of the squaring. So I'm not going to simplify this. I'm going to undo the squaring by doing the square root at the beginning. So, but I got to remember, positive and negative are possibilities here. So I'm going to get x minus 1 because I undid the squaring, but it's going to be equal to plus or minus 5. And a common mistake here is just to add the 1 and say you're done. But no, you got to realize there's 2 separate equations here. I got x minus 1 equals 5. I also got x minus 1 equals negative 5. And we're going to get 6, and we're going to get negative 4. 2 different solutions. 2 different solutions that are not just directly opposites. Okay, similar idea on the next one. Square root first. Don't forget the plus or minus. Write 2 separate equations. And I like to solve 2-step equations all at once. So I'm going to subtract this over, get 5 divided by 2. I'm going to get a fraction answer, 5 over 2, or 2.5. And subtract this one over, I get negative 7 divided by 2. So I'm going to get negative 7 over 2, or negative 3.5. Okay, now, as complicated as it gets right here, so I could technically square root first, but it's a little bit dangerous. So what I'm going to do is I'm going to divide by 4 first to get rid of it. Then I'm allowed to square root both sides. And what's cool about this is you can actually do this in your head. Division's pretty closely related to radicals, so we can evaluate these separately. Square root of 9 is 3, square root of 4 is 2, so we get plus or minus 3 over 2. And yeah, put a star by this one because this is the most complicated one. And then we got 2 equations to do. We got x minus 3 equals 3 over 2. We get x minus 3 equals negative 3 over 2. And let's see. So I'm going to think of this as 1.5 plus 3. So that should be 4.5. That's how I'm getting the answer on that one. Just seems easier. Think of this as negative 1.5 plus 3. I'm going to get a positive 1.5. But you could also write it as 9 over 2 and 3 over 2. Those would be accurate as well. Okay. On example 3, it says approximating solutions of quadratic equations. So class, sometimes you won't have perfect squares, you won't have nice answers, and you'll be expected to simplify or to round your answer, sorry. Notice to get x squared, we're gonna have to get x squared by itself and then square root. So we get 4x squared equals, let's add that 13 over 28 divided by 4, x squared equals 7. Square root. In class, square root of 7 is not nice. It's not a perfect square. So your exact answer would be x equals square root 7, x equals negative square root 7. But you can also get decimal answers. And just punch it into your calculator, see what the square root of 7 is, and we'll round it to 2 decimal places. I like 2 decimal places, 2.65. We have to round up because the we look at the second decimal place, the hundredths place, look to the thousandths place, it's a 5, so it rounds up to make 2.65. And the other possibility is negative 2.65. So yeah, exact answer, rounded answer, approximate answer. Let's try this next one. 5x squared equals 2, excuse me, divide by 5, x squared equals 2/5 square root. Don't forget the plus or minus. And yeah, you would actually have to rationalize the denominator here to get this to be the actual nice answer. So exact answer. So I'm going to skip that because I don't think we've talked about rationalizing denominators yet. I'm going to be a chicken and go ahead and get our rounded answer. I'm going to put square root 2 fraction fifths, and I get 0.63. Look to the right of the 3. I got a 2, so my 3 stays. 0.63. And you can write it like this, or you can split it up into 2 different problems. So class, I would like to do something that we actually have done, I believe, this year. So let's look at something like this. What if you had x squared equals 98? Well, you would square root it, don't forget the plus or minus. But what you could do is square root of 98 is not nice, but we've learned to reduce radicals. So what you could do, the easiest way to do this is to divide it by 2 and get 2 and 49. 49 is a perfect square. If you don't realize that, you'd go break it up into 7 and 7 and then circle the 7s. So class, what comes out is a 7 and a 2 is left over. And this would be your exact answer. That'd be your exact answer. And then you can punch in 7 square root 2 into your calculator to get the rounded answer. To the right of the 9 is 9, so we round the 9 up to make 10, so it's 9.90 plus or minus 9.90. And again, you could write this as 2 separate answers. So yeah, solving using square roots. There you have it. Have a good day.